this video tutorial. In this video, we're going to see how the nut and the bolt become together as a part, and we're going to have a look on their tolerances. So let's have a look on the tolerance classifications. Okay, here I have the external threads, which is the threads for the bolt, and here I have the internal threads, which is the threads for the nut. Here I have 4H and 5H. This is the first classification. This classification is used in industries, most in automotive and aerospace industries, where they need fine measurements and high accuracy. The second classification is a 6G with a 6H. This classification is the standard one, is a normal, is used in automotive and for light construction as well. The last classification, the 8G with the 7G, is for light constructions. Is for constructions that you don't need high accuracy, for example toys and stuff like that. So for the external threads, for the bolts, my major diameter for the classification of 6G, I get 9.968. So right now I have to go to the bolt, open the bolt file in SolidWorks, go to the tree list, open the extrude boss, expand the extrude boss by clicking this arrow, select the sketch, click on the sketch, edit sketch, click on this measurement, and type here this number, 9.968. 9.968. Enter. Exit sketch. Now I have to do the same thing with the nut. For the internal threads, for the nut threads, I have to look on the minor diameter. My minor diameter for the classification of 6H, I get the number of 8.676. So go to the tree list, expand the extrude cut, select the sketch, click edit sketch, and change the number here to 8.676. Enter. Exit sketch. Okay, right here I have my datasheet, which is telling me the major and minor diameter measurements. So this line here, the center line, is the axis of the screw thread. So this thread here is on the screw. But on previous tutorial, on the bolt tutorial, which explained how to create the screw, we designed the nut thread. So this might confuse you. So right now here, my major diameter is from the center of the bolt until the end of the threads. On previous tutorial where I create the threads for the nut, I designed the threads for the bolt. So you have to design the screw threads to create the nut, and if you want to design the bolt, you have to use the threads for the nut. So you have to understand what I'm saying here. You have to understand this. Okay, here I have the center line. Here I have the center line. This center line is the center from the screw axis. Is the center from the bolt axis. So what I'm looking here is to find the major diameter and the minor diameter. So the major diameter for the external threads is from the screw axis to the screw end threads. This is my major diameter. So as you can see here on the screen, the external threads bolts, my major diameter is 9.968. So from this center line to this to the end of the threads is 9.968 divided by 2. And for the internal threads, for the nut threads, this case here, I have to look for the minor diameter, this one. My minor diameter is from the center of the bolt to the end of the internal threads, to the top of the internal threads. So from here to here is my minor diameter, which is equal to 8.676 divided by 2. We divided by 2 because on the datasheet is a half. Go to the nut file, select, click on this line, select height, okay, now we're going to see how these two parts come together. Go to new, assembly, okay. So once you open the assembly environment, you have to select the M10 bolt, then go to the assembly, expand the assembly and select the origin. Then go to insert components to insert the nut, select the nut and place the nut anywhere you want. Then select this circle, this area, this line here, hold Control key, select the bolt diameter and make them concentric. Now you have to manage to place them exactly in this position. Let's see how we are gonna do that. By the way, previously we discussed about this center line here. This center line is the axis of the screw thread. So if you go to SolidWorks and then go to assembly, reference geometry, axis, expand the assembly, minimize your bolt and nut parts, select the front plane, hold Control key, select the right plane, select OK. Okay, this axis is the axis in the datasheet. That's why I said from the axis to the nut thread is a minor diameter divided by 2, because in SolidWorks and in the datasheet this is the half distance. Okay, but in this tutorial we are not going to divide anything, so we're going to place a number as it is in the datasheet here. Okay, that's this is just to explain the axis, just for to understand what I'm saying. Okay, delete it because we don't need it anymore. Yes. Go to the nut component, click on sweep cut, expand the sweep cut, select the sketch, select edit sketch, select the sketch, Control C to copy, exit sketch, go to the right plane, click on the right plane, sketch, select the section view. Okay, paste the sketch here, Control V, so right now this sketch here is a sketch that we use to create these threads, and this sketch and this sketch here is my bolt threads. So if you want to design the nut part, you have to design the bolt threads in the nut component. So this sketch right here is this sketch here. So if you want to create the nut component, you have to use the sketch for the bolt. The same thing is applied on the bolt. If you want to create the bolt component, you have to use the nut sketch. So it's opposite, but for the tolerances doesn't change anything. This is the bolt component, this is a nut component. So from there to there is a major diameter for the bolt. From here to here is a minor diameter for the nut. Okay, you have to understand the difference when you go to design the nut and when to go to find the tolerances. So right here, as we said, is the external thread. We use the external thread sketch, which is a bolt sketch. Right here we have to find also the distance from this point to this point here. You have to, this is very important if you want to find the tolerances. You don't need to make this measurement if you are not going to find the tolerances. Okay, on previous tutorials we just measure from this point to this point here because is the part that is going to cut the nut to create the bolt path. I don't know if you understand what I'm saying. Okay, right now we're going to measure, we're going to create these lines here. We're going to create these lines here. This one, and this one. This is only important, this measurement is only important if you want to find the tolerances. Okay, so use smart dimension from there to there. So from there to there is h divided by 4. It's h over 4. So I know that my h is 1.299. 1.299 over 4. Enter. And because we copy and paste that file, some information are missing. So use smart dimension here. Okay. Use measure this line here. It is not 1.5. Make sure that it is 1.5. Enter. Escape. Select this line. Hold Control key. Select this line and make them equal. Okay. Select this circle and delete it. So select your sketch from this point. Take your sketch around here. Hold. Make sure that this point is highlighted. Hold Control key. Select this part. Make them pierce. Now select the center line from this point to this point here. Escape. So right here we have to design the nut thread. So we have to go back to the bolt take the nut shape and copy paste on SolidWorks. So exit sketch, go to the Bolt file, expand the sweep cut, select the sketch, edit sketch, select this sketch, hold Control key and C key to copy, exit sketch, go back to the nut, select this sketch, edit sketch, hold Control key and V to paste. Go to the Move Entities, click this arrow here, select the Rotate Entities, click on this point, hold your left mouse, and rotate it to this direction. OK. Now here again I have to make the correct measurements. So here again I have to measure, I have to make sure that this distance is correct. So here my distance from there to there is h/8. Select Smart Dimension, click on this point to this line. I know that my h is 1.299, 1.299 over 8. Enter. Escape. Select the circle, delete it. Now again, because we copy paste the sketch, we have to make sure that every measurement is correct. Okay. If this is not 1.5, make sure that it is 1.5. Escape. Click on this line, hold Control key, click on this line here, make them equal. Now take your sketch from this point here, and take it around here. Now select the center line and delete it. So select the center line from this point. So right now we're going to design a center line from this point to this point here. From this point to this point here. Escape. Take your sketch from this point and place it here. Highlight, select your sketches, hold Control key and C key together to copy, exit sketch. Go to the Bolt file, select the right plane, click sketch, select the section view, select OK. Click on Helix and Spiral. Select Show. Hold Ctrl key and V together to paste the sketches. Escape. Select the point and place it around here. Escape. Select your point. Hold Ctrl key. Make them pierce. Escape. Select this point here and place it on this point we just created. Select this center line and make sure that it's horizontal. Exit sketch. Okay, going back to the assembly. Select yes. Minimize your nut tree list. As you can see, the sketches is not in the right position. You have to manage to bring them together. Go on display style, select the hidden lines visible and try to bring them as much as closer together. Okay, like this. Like this. Go to assembly. Go to reference geometry. Select plane. Expand the assembly tree and select right plane. Tap here 0. Enter. OK. Select this line. Hold Ctrl key. Select the plane. Make them coincident. Make the same thing for this one. Select this line. Hold Ctrl key. Select the plane. Make them coincident. Click on this sketch. Select Edit Sketch. Click on this line here. Make it horizontal. Edit component. Click on this sketch. Edit sketch. Make sure it's horizontal. Edit component. Click on this line, hold Ctrl key, select this line here. Make them coincident. Select this plane. Select section view. And click OK. Go to display style, select the first one. Okay, this is the last stage. Here, as you can see, my major tolerance is 0.236. You have to understand that we can't be 100% accurate, okay, to this number here. So right now we're gonna find this number here, the external thread tolerance. So to find that number, I have to click on this sketch, edit sketch, select the point, click on this point here, escape, edit component, go to evaluate, select the measure tool and measure from this point. Press the F key to bring it in the right position if you lost it. Go click on this point and this point here. As you can see, we got 0.22 millimeters. We are so close from the actual number, so we can be 100% accurate. For the internal threads, this is the external, okay? This is the external tolerance. For the internal threads, you have to get around this value. Escape, select the measure tool, click on this sketch, edit sketch, select the point, click on this point here, select escape, edit component, select, go to evaluate, select the measure tool, and from this point to this point here. As you can see, I'm very close from the actual number. 0.3, 0.28. These numbers are really close. Okay, make sure while you working on these sketches, make sure that all your lines, all your center lines here are horizontal. Okay, this is very important. Make sure that this line is horizontal, this one here, and this one, because if it's not horizontal, it's not gonna give you the accurate number while you are trying to find the tolerances. Okay, thanks for watching. I hope you enjoyed this video. I would like to hear your opinions, so write down in comments what you think about this and tell me if you want me to create something else for you. Please subscribe and like, and see you again.